Okay, so it says draw Lewis structures and use the helping hand to predict the molecule's shape. And just as a hint, we drew these structures back in number 4. So I'm just going to draw them in real quickly again, instead of taking the time to go through the process. So O3, if you don't remember, needed 1 double bond, 1 single. This is exactly the same thing if you drew it like this. Either one of those is okay. It's all about which direction you're looking from the molecule when you rotate it. The shape is the same, even though the shapes look very different to us. That's because we're seeing this 2-dimensionally. If I rotated this 90 degrees, it would look like that. It would look linear. So when you're trying to figure out shape, don't let the way you draw the picture mess you up. It's about what's attached to it. Ch8 remember, right? The C with an H and then a double bonded oxygen. So the only lone pairs are over on the oxygen. And then SiO2, the Si is double bonded to each oxygen, so it has no lone pair. So how do you determine a molecule's shape? Well, it depends on how many atoms are attached to it. Double bond is still only attaching 1 atom, so that doesn't count as 2 bonding sites or 2 bonding pair. It counts as 1. Think of it as a bonding site. The chart in your book's a little bit misleading. I think on the helping hand I called them bonding sites instead. If I've got 2 atoms attached and 1 lone pair, if you had 2 atoms attached and they could take up all the space they wanted, it would be linear. They'd be 180 degrees away from each other. But because you have a lone pair, what do lone pair always do? What does every pair of electrons do? Every pair of electrons repels every other pair, right? 2 is as many electrons as you can have in an area. So once you have a second pair together, so with this, each of these oxygens, it doesn't really matter if it's lone pair or bonding pair, pairs of electrons repel each other. If I didn't have a lone pair on this center oxygen, those two oxygen atoms would be as far away as they can. But there is a lone pair, so this is going to be a bent molecule. It's not trigonal because I'm looking at the center atom and what's attached to it. This is a bent shape, okay? This is still bent even though we drew it to look linear because that lone pair is still there. Okay, so whether we realize it in the way we drew it or not doesn't matter. My second one, how many atoms are attached to it? So we'd say 3 atoms, and this is always on the center atom. How many lone pair on the center atom? So if you have 3 atoms that can spread out as far away from each other as possible, how far apart can they get? That's 120 degrees, but what would the shape look like if all 3 of them could be as far away as possible? This is what we call trigonal planar. It's forming a triangle, the 3 atoms attached to the center atom. These 3 atoms form a triangle around the center atom, and they're all in one plane, keeping them as far away as possible. Whereas up here, they only form a bent shape. Bent is also called V-shaped. V-shaped is maybe a better way to think of it with that center atom. And then SiO2, looking at the center atom, you've got 2 atoms attached. No lone pair. So unlike the first one where you've got a lone pair bending it, this will be linear. And you will have the chart. You'll have a helping hand, the last page of your test that you can just pull off and use.